Cable technology. Do you know what is cable technology? Well, cable technology is something that is so cool. It uses lots of cables and sometimes you might be wondering what's inside it. So, we should study about this to know about cable technology, to know more about it. Let's go. Modern telecommunication relies on the accurate and rapid transmission of large volumes of information. Cables, the original information conduits, remain central to telecommunications networks. Despite developments in satellite technology, advances in cable technology have led to the development of telephone trunk cables that can transmit tens of thousands of calls simultaneously. Coaxial cable. Coaxial cables have a central copper core running through the center of a cylindrical copper braid. The two conducting channels are separated by a layer of insulation. The inner channel carries information as modulated radio frequency alternating currents, while the outer channel gives protection against electromagnetic interference. Coaxial cables are used in telephones, computer, and cable TV networks, and to link TV aerials and to receivers. Cool. Communication over long distances is achieved by the transmission of data as waves or streams of pulses. An electric current alternating, switching direction as radio frequency is modulated, shaped by an analog or digital data signal. The modulated wave is sent through coaxial cables or broadcast via ground stations and satellites as radio waves. Digital information may also be sent as streams of light pulses or less commonly of electric pulses. That was so cool. What do you think? That is so cool. Do you ever see a cable technology? Let's continue reading. A pulse presenting a 1 and the absence of pulse representing a 0. Cables act as highways for these data streams and must be designed to minimize interference between different data streams, which leads to loss of data. The bandwidth of a cable is a measure of the amount of data that it can transmit. Optical fibers have a greater bandwidth than coaxial cables and can transmit signals better and farther since light is less prone to attenuation, power loss than electric currents and propagates faster. The bandwidth of a cable system can be increased by installing more cables, but also by employing multiplexing techniques which squeeze more data down each cable. Outer sheath. So plastic sheathing protects the cable from damage. Transonic cables, remotely operated vehicles, OVs, are usually submarine cable just under the ocean floor at depth up to 1,000 meters, 3,300 feet below sea level. The cable is buried in furrows up to 3 meters, 10 feet, into the seabed to protect it against hazards such as trawler nets, deep sea currents, and seismic activity. Wow, that's so cool. Radio frequency electric signal. Coaxial cables carry digital or analog information. Central copper core. The core is made of copper, one of the best electrical conductors, and carries information as high frequency alternating current. insulation. A layer of insulation material keeps the two channels separated. Copper wire braiding. The outer channel conducts electricity to ground and protects the core channel from the interference. Outer sheath. The plastic sheeting protects the cable from damage. Wow, that is so cool. Transoceanic cables. Yeah, that's right. That's so cool. Now let's move to optical fiber cable. You ready? Let's go. That is like so cool. Do you ever wonder that? Sometimes it has to be like that. It's cool. Let's see what the optical fiber cable like. Optical fibers are high thin strands composed of two layers of very pure glass or plastic. An outer cladding layer conveys light signals to the inner core by a process called total internal reflection. A plastic sheath protects the fiber from damage. Digital information is transmitted as bursts of light. However, excuse me. However, transmission is not flawless. Each pulse may travel along several paths or modes through the fiber and tends to gradually spread out. So a clear input pulse becomes blurred and loses intensity as it travels. This pulse dispersion limits the rate and the range of data transmission. Single-mode fiber. Single-mode fiber has a narrow core which confines light through traveling along its axis in a single path or mode. So here's a very little pulse dispersion. Light of a coherent wavelength must be used, so a laser is used as the light source. Single-mode fiber is used for long distance telecommunications. Ooh.
Nookie.
Cool. That word is called Nookie. Ooh, that's fun. Eight. What's it about it, Ella? Alright, yeah, I know. That is so cool. Okay. So that's so cool. Look at this. Input output signal. Look at that. Input output signal. Ooh, input signal and output signal. Let's see what's the differences. Signal, core, cladding, protective cells, light bursts, light rays travel along a single path along the axis of the core. Strengthening steel core. Graded index fiber. These fibers are used to transmit information over local area networks. Light bursts, light rays zigzag down the core by bouncing off the cladding. Optical fiber. Plastic shells. An upper core, outer shells prevents stray lights entering the fiber. Protective layer for trunk cable. Light bursts. Light rays. Yes, right. Step index multimode fiber. Like graded index fiber, this type A fiber has a wide core that allows multiple light paths. These paths vary in length and cause much dispersion. Step in next fiber is ready for use where only short lengths of fiber are required. For example, in endoscope tubes, multimode fibers may be used with light-emitting diodes, LEDs, as resources rather than expensive lasers. Wow! Graded index multimode fiber. Because of the variations in density of the fiber core from the center to the edges, light traveling along the shorter path down in the center travels more slowly than light at the edges. Thus, the light rays that make up each pulse reach the receiver at almost the same time, irrespective of the path, resulting in relatively little pulse dispersion. Dispersion. That is like so cool. Let's look at this. Okay. So we are gonna see.
Megalodon.
Cool. Let's see this. Wow, a large South American snake. Cool. What's that for? Multiplexing. Ooh, multiplexing. Easy peasy. So let's look at this. Multiplexing increases the capacity of cable systems by increasing the bandwidth of each cable. Multiple data streams are sent down a single cable by combining them to form one complex signal. Streams are then separated at the output end of the cable. Time division multiplexing TDM interleaves streams of digital data, allowing many data streams to be sent into a fraction of the time that would be needed to send them separately. Frequency division multiplexing FDM sends thousands of streams at different frequencies. TDM and FDM can be used together to maximize cable bandwidth. Cool. We finished one chapter. And it is like so cool. Cool. So cool. Radio waves are a type of electromagnetic radiation that is all around us, generated naturally in electrical storms and constantly flooding the skies from outer space. The discoveries that things could be used to transmit information revolutionized the early 20th century world. Today, radio waves are used by traffic guidance, cell phones, satellites, communications, and radar, as well as TV and radio broadcasts. What? It's so cool. Yeah, what wonders that? I do. Okay, well, this is nothing. Wow, do you wonder what a radio would be like? A radio is something that you hear. I'll show you one type of radio. Are you ready? Let's go. So this is a radio. It's used for listening. You see, it just look like a radio. There's a lot of us that turn on the power. And you see, turn it on. Like that. So we could listen to like a report or something. But radio is much more smaller than this. And sometimes you can carry it like away to hear. To like hear the step. Here. That's right. Isn't just that we want to hear it? Isn't that cool? Wait. Okay. So, radio waves are electromagnetic radiation with wavelengths between about 1 millimeters, about 0.4 inches, and 10 kilometers. And 10 kilometers, 6 miles or more. Now, they are often described by frequency measured in hertz, cycles per second, which ranges from 3 kilos to 300 GHz. Okay, Marconi. But some this I need to like. I don't know this word. Gog. Mommy, come in here. Mommy, come in here. Mommy. Come in here, Mommy. I need to ask you something, Mom. Wait a minute, I will tell Mom. Too difficult that he didn't even know. I read that one now. That's right. I want to read that one. It didn't work. Oh God. So what's one now? Oh, everyone, I think we should read this one next time. Let's continue. So, Marconi sent the first Morse code messages using simple pulses of radio waves in 1895, and methods of modulating them, altering the waveform by superimposing a sound or other signal to carry complex information data were invented shortly afterwards. Radio waves may be either amplitude modulated AM or frequency modulated FM. The signals of FM radio broadcasts have bandwidth than those of AM broadcasts. That is, they occupy a wider range of frequencies. Electrical bleeps and random radio noise from the atmosphere diminish in the the amplitude radio signals, but do not alter their frequencies. This means FM broadcasts are less prone to interference than AM broadcasts used by radio stations and other transmitters are regular by international agreements. So just like, ooh, you can see I have this radio finger. It's also wet. Ow! 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 That has hurt so much. Cool, isn't it? I will put a picture to radio. Radio. Here, look at this. This is a radio. Is that a picture right there? That is a radio. A radio is just like that, and sometimes it is different. Look at that. Okay, cool. So, that is right. So, radio broadcast. A radio transmitter works by generating an electric carrier wave at the same frequency as the required radio signal. There is superimposed onto the carrier in a process known as modulation. A transmitter feeds the modulated signal to a mast where the fluctuating current generates a radio signal that reflects the shape of the modulated carrier wave. Radio waves are usually multidirectional, and the signal's range depends on its frequency. A receiver picks up all frequencies, but uses a turning circuit to extract one specific signal that is then modulated to extract the original data. Wow! Ooh, that's right, like connecting from our house. This one is going all the way to this one. And this one's going to zigzag line. And this is the red one, that's mine. Like this. It's like, yeah. These are going round. Whoa. So, let's move on. Wow. We're down to our last chapter. The satellite communications. Couldn't you believe it? It looks so cool. Oh, okay. Okay. Cool. Let's talk about satellite. Satellite. Light. You won't believe this. A satellite. A satellite is a device sent up into space to travel around the Earth, used for collecting information or communicating by radio, television, etc. Cool, isn't it? Ooh. So, that is so cool. Let's see. Since the launch of the first satellite, Sputnik 1 in 1957, satellites have revolutionized information broadcast and the collection of data. Communications satellites relay TV pictures, telephone calls, and internet data from one part of the Earth to another using microwaves that travel at the speed of light. Outside the satellites gather data on the weather, monitor environmental and urban changes, locate mineral deposits, and transmit navigation signals. Wow! In the last 40 years, several thousand satellites have been launched by rockets and rechargeable spacecraft such as a space shuttle. If a satellite is traveling at the appropriate speed for its altitude, the gravitational attraction of Earth pulls it into a circular or elliptical orbit. Most communications satellites travel in high geostationary orbits, in which they revolve around the Earth at the same rate as the Earth rotates, so they maintain their position above the Earth's surface. These satellites are usually put into a low Earth orbit before being transferred to their final orbits by onboard engines and the final stage of the launch vehicle. Once in the desired orbit, a satellite uses photovoltaic cells fitted on extended solar panels to generate electrical power for its operating systems. Gas thrusters and gyroscopes are used to maintain the satellite's orientation and keep its aerials pointed towards Earth. Communication satellites receive data in the form of radio signals from transmitters on Earth, uplink and relayer signals, aerials. Due to the increasing volume of data being transmitted via satellite, the microwave bands currently in use are in danger of being exhausted. To provide extra capacity, NASA is testing satellites that uses higher frequency microwaves. Ooh, look at that! Elliptical orbits. Satellites in elliptical orbits are able to transmit to high latitude regions. Geostationary orbit. A satellite in this type of orbit maintains the same position above a point on the Earth's surface about an altitude of 35,900 kilometers, 22,440 miles. Wow! Polar orbit. Remote sensor satellites uses this type of orbit because it enables them to monitor the entire planet as it rotates below low orbits. The orbits typically lies at an altitude of 160 to 320 kilometers, about 100 to 200 miles. Yeah, I like the low Earth orbit because it's moves around the Earth to get information and signals. That's what I'm talking about. So I want to learn about that. Isn't it cool? Wow. The satellite is so big. Did you ever what the satellite is? So, finish reading a book and satellite is so big. It rotates about the Earth. It rotates and rotates. You ever see the satellite before? Well, it orbits a lot. It's like, yeah, that's right. Look at that. A satellite is from top of Earth and it can record every system that I wish I could transfer it to you. Yeah. Cool. Cables. Couplets? You know. This is so cool. And not also that. Let's look again. Let's look again at the satellite communication. Look at that. The radio. Actually, I need this picture. See? And the cable technology. That's right. Yes, that's right. Cable technology. That's what I'm talking about. Okay. Cable technology. Cool, isn't it? So, that's what I'm talking about today. Nope. Do you see that is so cool? When we study about cable technology, you really good today. And I appreciate it. Thank you for listening to my reading and see you soon. Goodbye, everyone. See you later and have a nice day.